This video is on compound inequalities. Compound inequalities are when you have two inequalities on one graph. They're either being graphed outward or inward. So our first example here, we have an outward graph, which is an OR problem. So we have the arrows going outward. And problems, on the other hand, are going inward. In our first example, we have x minus 4 is less than negative 7, or 2x is greater than or equal to 12. So we solve each of these inequalities, and when we do that, we end up with x is less than negative 3, or divide both sides by 2, x is greater than or equal to 6. So give yourself enough room on your number line here. So I'll go negative 4. Okay, so now that you have your graph made, you need to complete it. So we have x is less than negative 3, so that's an open circle at negative 3. And it's saying all values less than negative 3. So you'll shade to the left. And then we have x is greater than or equal to 6, and that would look like this, and that's why it's an outward graph. Now, if we wanted to write this in interval notation, it would be an open bracket there, parenthesis, from negative infinity to negative 3, and that's in parenthesis because it's open, or we'd have a bracket because it's closed at 6 to positive infinity with a parenthesis. In this example, we need to be careful because we have a negative 3 that we must divide by. So I like to circle my inequality to remind me that we're going to have to flip our inequality. So we have x is greater than or equal to 3, or over here we'll subtract 5 from both sides, and we have x is less than 1. So on our number line, we can go, let's go 0, 1, 2, 3, 4. And I'm going to have a closed circle at 3. And it says that we are all numbers greater than or equal to 3, so we're actually going to shade to the right. And our other one says x is less than 1, so we'll have an open circle at 1, and it's all numbers less than 1, so we will be shading that to the left. Our interval notation will be open parentheses, so open negative infinity to 1 parenthesis, or we'll have a bracket because it's closed at 3 to positive infinity. The next type here is what we call an AND problem. So we have 2 is less than or equal to x plus 4, which is less than 9. So to solve this, you work from the inside out. So what we do to get this x by itself is we subtract 4 from both sides of the inequality. So you have to do it actually 3 times, because what happens is cancel those, which we wanted, but we have to keep it balanced. So 2 minus 4 is negative 2, which is less than or equal to x, which is less than 5. Now this might look a little intimidating, but you can kind of break it into parts. So this is actually saying negative 2 is less than or equal to x, and you can break this part, which would be x is less than 5. And if you were to graph this on a number line, so let's go negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, and 6, we are going to have a closed circle at negative 2, and it's saying all numbers greater than negative 2, so we're going to go that direction. But then the other inequality says x is less than 5, and it's an open circle, and so it's this way. So it's saying that our solution to this inequality is going to fall somewhere between negative 2 and approach 5. In interval notation, how we would write this would be closed bracket at negative 2, and it would be open at 5. And our solution falls somewhere in there. In our next example, we have negative 14 is less than 7x, which is less than 21. And in a problem like this, you have to get x by itself, so you just divide every single thing by 7. You have to be fair, so you keep it balanced and do it to both sides. And you end up with a negative 2, which is less than x, and less than 3. So on a number line, we would have -3, -1, 0, 1, 2, 3, and 4. And we have an open circle. Oh, I messed this part up. Let's see here. Let's change this to a -2. We have an open circle at -2 and an open circle at 3, and our answer is between these two values. So remember, you could write it like this part here. So you have -2 is less than x, and x is less than 3. It's just another way to think of it. But your solution falls somewhere in between here. So in interval notation, we would have open parenthesis -2 to 3, which is also open. So those are two types of compound inequalities: or problems and problems.